Hi there, I'm Anchal and I welcome you wholeheartedly to this session. I hope you're enjoying the subject till now. Today, we'll be talking about radius of gyration. So, radius of gyration is basically related to moment of inertia. Therefore, before getting into details of radius of gyration, let's first briefly recall the concept of moment of inertia. So, the role played by mass in translatory motion is played by moment of inertia in rotational motion. So let's say I have a arbitrary shaped object which is rotating about a fixed axis with angular speed omega. Now the total mass of this object is m, and this object is basically made up of infinite number of small point masses, and the distance of each point mass from the axis of rotation is different. Let's say this is a point mass m1 which is at a distance r1. This is a point mass m2 which is at a distance of r2, and so on. Now the total moment of inertia of this object will be equal to addition of individual moment of inertia of these point masses. So the total moment of inertia of this object, I will call it I naught, will be equal to m1 r1 square plus m2 r2 square till mn rn square. Now the point is, the analysis of motion of objects whose mass is not concentrated on one point is always difficult. So what we do is that we try to find a point where we can consider that the mass of complete object is concentrated, but the properties of this point mass, this hypothetical point mass, should be exactly similar to the properties of the complete object. Radius of gyration is based on the same thing. So let's say this is my object whose mass is distributed throughout its body, right? And I know the moment of inertia of this object is I naught. Now what I'm going to do is that I'm not going to change the axis of rotation, and I'm not going to change the mass of the object, but I will consider that the mass of this complete object is concentrated on one single point, and this single point is kept at a distance k from the axis of rotation. Now the moment of inertia of this hypothetical point mass about the given axis of rotation is, let's say, I1, which is equal to mk square. Now this k will be called as the radius of gyration of the given object about the given axis of rotation if the moment of inertia of this hypothetical point mass is exactly equal to the moment of inertia of complete object. So what I want is this I1 should be equal to I naught. That means mk square should be equal to I naught, and hence k should be equal to root over I naught by m. And this k is basically called as radius of gyration. Now remember few things. To find radius of gyration, you must not change the mass of the object, you must not change the axis of rotation, and you must not change the moment of inertia, right? The only thing you can do is that you can consider the complete mass of this object to be concentrated on one single point, and this single point will be hypothetical. So let's have an example now. Let's say I have a thin rod which is rotating about an axis which is passing through one of its end and is perpendicular to its length. The mass of this rod is m and the length of this rod is L. Now I know that the moment of inertia of this rod will be equal to ml square by 3. Now if I'm asked to find the radius of gyration of this object, what I'm going to do is I'm going to consider the mass of this rod to be concentrated on one point, and this point is at a distance k from the axis of rotation, and now this point is in rotational motion. The moment of inertia of this point mass will be equal to mk square. Now k will be called as the radius of gyration if this I1 becomes equal to I0. That means mk square becomes equal to ml square by 3, and k will be equal to L by root 3. So rotation and physics are full of these kind of concepts. I hope you have clearly understood the concept of radius of gyration. In the coming sections, we will be talking about some more interesting concepts. Till then, happy physicsing!